Hey guys, this is the video review for test number 6, or you can think of it as test number 1 for spring semester. Okay, so let's get started. So number 1, like I said in class, is a freebie. Everybody should get this question correctly. It says, do the following represent functions? And in order to answer this question, you need to use the vertical line test. Okay, which means that if I draw a vertical line through any of these, if I hit it more than once, if I cross it more than once, then it's not a function. If I cross it only once, then it is a function. Like for example, that one. That one, I crossed it twice. I crossed it here and here. Crossed it twice with a vertical line. And if I cross it with any other vertical line, I'm always going to cross it twice. So as long as I hit it more than once, it's not a function. This is not a function. No, part B. No matter where I draw a vertical line, as you can see here, I can draw many vertical lines, but no matter where I draw it, I only hit it once, right? Once per line. So I only hit it once right there, 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 and so on. Since I only hit it once, then yes, this is a function. Same thing for C. Draw vertical lines anywhere, and you can see that you only hit it once. So once again, yes, that is a function. And D, if you make vertical lines anywhere, it looks like I hit it twice every time. So that one, no, it's not a function. Okay, number 2 is asking you for the domain and range of each of the following functions. I said in class that domain of all absolute value functions is always the same thing, all real numbers, meaning that the graph keeps going to the left forever and to the right forever. So I'm going to go ahead and write the domain for all of these. That's all real numbers. And I know that these are absolute value functions because of the V shape that they make. That's what absolute value functions look like, right? It's symmetrical V shape. Either going up or going down, but it's a V shape. So the domain for all of these is going to be all real numbers. All of them have the same domain. That's always the case for absolute value functions. The range, however, is different. For the range, what you need to do is identify where the vertex is, which is right here, right? That point of the graph, that's called the vertex. Identify what that is. In this case, it's 1, 1. And from the vertex, what you care about is the k value, right? Remember, it's h, k, right? The x value is h, the y value is k. The k value is what tells you the range. So what you're going to do for the range is you're going to write the range is all the values of y, and what you're going to do is you're going to compare it to the k value, which is 1. So you're going to write y and also 1. And what I mean by compare it is right here between them, you're going to write an inequality symbol. Either you're going to say that it's greater than 1 or less than 1. How do you decide? It's based on the absolute value function and which way it's going. If it's going up, like these two, right? The arrows are going up. That means that the values of y are greater than or equal to 1. We have to include the equal sign because that means it passes right through 1. So what it's saying is that the y values of this function are always going to be 1 or bigger. Okay, which means that this graph never goes below 1. Never goes below that. It always exists above that. Let's try it again. Watch. Take B, find the vertex, which is right here. It is -2, 2. What you care about there is the k value, which is the 2. So what you write is the range is y, and then you also write a 2, and then right here you're going to write an inequality symbol that tells you if it's going up or it's going down. So if you look at the graph, the arrows are going down, which means that the graph only exists below that point. So you're going to use less than or equal to 2. For C, let's see, we're going to write the range. And let's see, let's find the vertex. It's right here, which is -2, -3. Once again, what you care about is the k value, which is the y value, which is -3. So you're going to write y. These arrows are going up, right? So greater than or equal to -3. That's your range. So hopefully you're getting the hang of it now. Let's do it one more time for D. We're going to write the range, and we're going to write y. Let's find the k value by finding the vertex. Here's the vertex. That's 3, negative 2. What you care about is the k value, which is the negative 2. So you're going to write y is less than or equal to. Why less than? Because it's going down, right? The graph only exists below that point. Less than or equal to negative 2. And that is the range. Okay, number 3, it says graph each function. These are inequalities, so you're going to graph and then shade after you graph. Okay, so let's start with A. The first thing you do is identify what the slope is. And you get the slope by looking at the graph and seeing it's y equals mx plus b, right? It's in slope-intercept form. And you write m equals 3. And then you write what the y-intercept is, which is the b value, which is negative 2. And remember what I keep saying about those two values? B means begin. That's where you start your graph, always on the y-axis. M means move. That's how you move your graph. What I'm going to do is I'm going to write that 3 instead as 3 over 1. Because that's more explicit instructions of where to go. Now it says go up 3, go right 1. So you begin at negative 2, put a point there. So on my graph, I'm going to start at negative 2 right here on the y-axis. Put another one at, put that one at negative 3, at negative 2, and then use the slope to move. You're going to go up 3. The number on top tells you to go up or down. The number on the bottom tells you to go left or right, depending on the sign. So this is positive, this is positive. That means up and to the right. So you're going to go up 3. That means 1, 2, 3, and to the right 1. Right here. Right here is where you put it. You could make more. 1, 2, 3 over 1, like that. There's your graph. And now you draw your line. Before you draw your line, check right here. Check the inequality symbol to see if it's less than or greater than, or if it has an equal sign or if it doesn't. If it has the little equal bar below, that means the line is solid. If it does not have the equal sign, that means the line is dashed. And if it's less than, that means you're going to shade below the line. And if it's greater than, that means you're going to shade above the graph. Okay, so in this case, there's an equal sign, so it's solid. So make a solid line through that, through those 3 points that we drew. And then the inequality symbol is less than. So we're going to shade below the graph. Below means down, right? From the line, shade down. So all of this space right here is below the graph. So we're going to shade it all in like this. And there you go. Let's do it again. B. Same thing. Find the slope, which is m. It's 3 again, so 3 over 1. Find the y-intercept, which is b. It's negative 2. That means begin at negative 2, once again. Move 3 up over 1. 1, 2, 3 over 1, right there. 1, 2, 3 over 1, right there. Before you draw your line, check. Look at the inequality symbol here. There is no equal sign there. That means make a dashed line. Not a solid line, a dashed line. Like that. And finally, look at the inequality symbol again and see it's greater than means shade up, shade above. Less than means shade below. This is greater than, so shade up, shade above the line that you just drew. So all of that stuff is your solution. Alright, I'm going to let you guys work on C and D on your own. Go ahead and do them on your own, please. Pause the video right now and come back to see the final answer. Go ahead and pause the video right now. Okay, here are your solutions for C and D. In C, I made a dashed line because it says dash here. The y-intercept is 2 and the slope is negative 3 over 1. So I started at 2, went down 3 over 1 and made a dashed line. It's also less than, so I shaded below. In D, the y-intercept is 2, so I started at 2. The slope is negative 1/3, so I went down 1 over 3. It's a solid line because of the equal sign. And it's greater than, so I shaded above. Right, number 4, solve each equation. Absolute value of 3x minus 5 equals 5 is the first one. Let's get started. We did some of these, we did a lot of these actually in class last week, so you guys are pretty familiar with these, okay? Absolute value equations, the steps are to solve it twice. Basically, right away, if you see that the absolute value is isolated, which it is in this case, you'd write 2 equations using the numbers that are given to you. So in the first equation, notice that I wrote everything exactly the same. Nothing changed. In the other equation, I changed the 5 to negative 5. Now I'm going to solve both. On the one on the left, I'm going to add 5 to both sides to cancel the 5. I'm going to get 3x equals 10. And then I'm going to divide by 3. And there's my solution. X equals 10 thirds. Or the other possibility, we're going to solve the other one. We're going to add 5. That one cancels, so it's 3x equals 0. We're going to divide by 3. And x equals 0, because 0 divided by 3 is 0. There's your two solutions. Let's do it again. Let's go to B. Absolute value of 4p plus 3 equals negative 9. I start to split them up because that's the steps that I'm supposed to follow, but I notice that its absolute value equals a negative number. And that should ring some alarm bells in your head, because the absolute value of anything is always positive. So this is a positive number, right? The absolute value of anything is positive, or 0 if it happens to be 0, right? It could be positive or it could be 0. So what you're saying with this equation is that there is a positive number that is equal to negative 9. That's impossible. So we don't continue. We say there is no solution to this. No solution at all. Okay, so with those two examples, you guys should be ready to do C and D on your own. So go ahead and do C and D on your own right now. Pause the video and then come back and see the final answer. So go ahead and pause the video right now. Okay, here you go. For C, what I did is I split it up into two parts like we do, because this is a positive number, so you got to keep going. And the absolute value is already isolated, so all I had to do was just split it up. I got negative 2x plus 4 equals 8 on this side. I subtracted 4, I divided by negative 2, and I got x equals negative 2. For the other part, I kept everything the exact same way, except that I changed the 8 to negative 8. And then I followed the steps, the exact same steps. I subtracted 4 and divided by negative 2. But in this case, because I'm subtracting from a negative 8, I got negative 12. Divided by negative 2, I got 6. So the two solutions are x equals negative 2 or x equals 6. For part D, I noticed that the number on the right side was a negative. And that's impossible because this is an absolute value, which is positive. So it's saying that there's a positive number which is equal to negative 2, so no solution. All right, let's do that again. Number 5, same idea, absolute value. Okay, so for part A, here's what I'm going to do. I am going to first kick out the 3. Because the absolute value is not isolated, the first thing you should do is isolate it. Meaning that there should only be absolute value by itself, nothing else outside of it. Everything else must go to the other side. So I notice that there's the absolute value and then a minus 3. I kick out the negative 3 to the other side. So I get absolute value of 3x minus 2 equals 10. Now I am going to solve that by splitting it up into 2. So I'm going to go that way and that way. On this one, what I'm going to do is I'm going to keep the exact same equation. 3x minus 2 equals 10. And we're going to solve it by adding 2. The equation, again, does not change, right? It's everything exactly the same. Just 3x minus 2 equals 10. We added 2, we got 12. We divide by 3, we get 4. X equals 4. On the other side, the equation looks different. It's 3x minus 2 equals negative 10. On this one, we're going to add 2 to both sides also. We're going to get 3x equals negative 8. We're going to divide by 3. And we get x equals negative 8 over 3. And that is your final answer. One positive, one negative. Alright, in B, we're going to follow the same steps. First, we're going to kick out the 2 to isolate the absolute value. Do not try to split up at this point. This is one of the common mistakes. People will say, I'm going to solve this, and then I'm going to solve it again with negative 1. And they're going to get the wrong answer. Okay. First thing you do is kick out this 2 to isolate the absolute value. So when I kick out the 2, I get 7z, absolute value of 7z plus 3 equals negative 1. And just like in the problems above, I stop there. I'm done. Because the absolute value of 7z plus 3 is positive. And this is saying that there is a positive number which is equal to negative 1, which once again is impossible, so no solution. Only do this this part where you check if it's positive or not, once you have isolated the absolute value. Because it will happen sometimes that there's a negative there, but when you do isolate the absolute value, it turns positive for some reason. Okay, so check. Once you isolated the absolute value, check if this is negative. And if it is, you say no solution. Alright, so I want you guys to try C and D on your own. You should do C and D on your own, practice them first, then come back and see if you guys did them correctly. Okay, so C and D are for you. Pause the video right now, and then come back to see the final answer. Okay, here you go. These are the correct solutions for C and D. In C, I subtracted the 5 first, and I got 4. And then at that point, I split it up into two, one with positive 4, one with negative 4. On this side, I subtracted 3 and I got 1, and then I divided by 4 to get 1/4. On the other side, I subtracted 3 to get negative 7, and then I divided by 4 to get negative 7 over 4. So those are your two solutions. B equals 1/4 or B equals negative 7/4. For part D, I also subtracted 3 and I got negative 5, but at that point I stopped because it's saying that the positive number is equal to negative 5, so therefore there is no solution because that's impossible. Alright, let's move on to number 6, which are absolute value inequalities. Very similar to the absolute value equations, but these are inequalities, which means that it's either going to be an AND inequality or inequality after we solve it. Okay, so for this one, the first thing I'm going to do is check that. For part A, I'm doing A. The first thing I'm going to do is check if it's AND or by writing a little vertical line there to see what kind of letter I make. That's a D, so that's AND. This is an AND inequality. So that I know when I solve it that it's supposed to be shaded in between because AND inequalities are shaded in between. Okay, so here we go. Let's solve it. I'm going to split it up into two just like we were doing for the equations. On one side, it's x minus 3 is less than 4, which is the exact same inequality that you start with. On the other side, you do x minus 3 is greater than negative 4. So you change the inequality symbol, you change the sign of the number. And now you solve them both. On the left side, all I have to do is add 3 and finished. That's done. X is less than 7. On the other side, you have to add 3 also. It's the same step, but you get a different number. X is greater than negative 1. And then what you do is you write the word AND in between to show that it's an AND inequality. There's your solution. AND inequalities have two ways of writing them. So you could write it like this, or there's another way of writing it which looks like this. You start with the smallest number, which is negative 1, and you write less than x, less than the biggest number, which in this case is 7. If these symbols were less than or equal to, or if they had an equal sign underneath, then I would put that there also. But that's the other way of writing AND inequalities. That's a short form of writing it. And then finally, it says to graph them as well. So let's do a quick number line to graph them. All you care about this in these graphs is to find the numbers that are there in your inequality. So find negative 1, find 7, put circles on both of them. Check if those circles are supposed to be open or closed by looking for the equal sign here. Both of these are open. And then since an AND inequality, you shade in between. So shade in between right here. And you're done. Let's move on to B. Absolute value of 2x plus 7 is greater than 5. Same thing as before. First thing I'm going to do is check if it's supposed to be AND or. Right? Draw a vertical line like that, and you see that you make a letter B. That means or. A letter D means AND. So this is an OR inequality. And just like the other one, we're going to solve it twice. First, I'm going to keep the exact same numbers, the exact same inequality. Nothing changes. 2x plus 7 is greater than 5. We're going to subtract 7. 2x is greater than negative 2. Divide by 2. X is greater than negative 1. Done with that one. For the other one, you're going to keep the same numbers, but you're going to change the 5. So it's going to be 2x plus 7. You're going to change the inequality to less than, and you're going to change the 5 to negative 5. You're going to subtract the 7. You're going to have 2x is less than negative 12. You're going to divide by 2. And you're going to get, oops, I just changed the less than symbol to equal. So let's erase that. It shouldn't be equals. It should be less than. less than negative 6. And you're going to write the word or in between. And there you go. Or inequalities only have one way of writing them. There is no other way. It's either with the word or in between, or that's it. There's no other way. Okay, so that's it. There is no short way. But we do have to make the graph. So here's your number line. Find the two numbers, which are -1 and -6. -6 is over here. -1 is over here. Put circles on both of them. Check if they're open or closed. If you see an equal sign here, then they're closed. If not, they're open. So leave both of these open. And then check if it's an or and. Since it's or, you shade in opposite direction. So you're going to shade that way for that one and that way for that one. And there you go. That's A and B. Now you guys are going to do C and D. So go ahead and work on C and D on your own. And then come back and check the correct answers. Okay, so go ahead and pause the video right now. Work on C and D. Then come back and check. Okay, here you go. These are the correct solutions for C and D. In C, it's an and inequality. That's the first thing I checked. I got a D. And then I split it up into two. Once with a +2, the other one with a -2. On this side with less than, and on this side with greater than. And I solved them both simply by kicking out the 5, and I got x is less than -3, x is greater than -7. And since it's an and inequality, I write the word and in between. And then I wrote it in the other form by putting the numbers in order from smallest to greatest and the x in the middle. And then I graphed the number line and shaded in between because it is an and inequality. In D, I checked first what type of inequality it was, so it's or. I split it up into two, so I got x minus 2 is greater than 8, x minus 2 is less than -8. I kicked out the 2 on this one, and I got x is greater than 10. I kicked out the 2 on this one, and I got x is less than -6, and the word or in between. And like I said, there's only one way of writing this, right? We don't have two ways like for and inequalities over here. So one way of writing this, and then this is the number line where I graphed it. Here's the -6, here's a 10, and since it's or, we shade in opposite directions. Right, number 7. Which of the following inequalities are equivalent? Okay, equivalent means that they have the same solutions. Okay, so if I solve them, they should have the same solutions. So what it's asking you to do is to solve them. Solve them to see which ones are equivalent, which ones have the same solutions. So let's start with A. 3 times 2x minus 5 is less than 4 minus 3x. I'm going to solve this first by distributing. So I'm going to get 6x minus 3 times 5 is 15. Right? When you distribute, you got to do 3 times 2 and 3 times -5. Is less than 4 minus 3x. Next, what I'm going to do is I'm going to collect the x's on the left side. I want the x on the left side just so that I can compare them. So what I'm going to do is I'm going to add 3x to both sides to get rid of it on the right side and move it to the left side. That's 9x minus 15 is less than 4. Next, I'm going to add the 15 to cancel it. Add the 15 to cancel it. That cancels. So I get 9x is less than 19 because 4 plus 15 is 19. Alright, I'm going to continue over here. 9x is less than 19. I'm going to divide by 9 and x is less than 19 over 9 is your final answer. Alright, let's do it again for B. In B, I'm going to do the same thing. I am going to collect the x's on the left side. I'm going to try to make it look like this one so that the x is by itself on the left side. Okay. So what I'm going to do first is I'm going to subtract 11x to send it over to the left. That cancels there, so it's going to be 5. 2 minus 11 is going to be -9x. Is greater than -14. Next, I'm going to kick out the 5. I'm going to subtract that one also. So -5 goes to both sides. That cancels there. So it's just -9x is greater than -19. Next, I'm going to divide by -9. Divide by -9 to get rid of the 9 and leave the x by itself. It's going to cancel there, leaving me with, I'm going to continue over here, leaving me with just x. Since I'm dividing by a negative, every time you divide by negative, don't forget you have to flip the inequality symbol. So it must go to the left now. So it's less than. And -19 over -9, negative over negative is positive. So it's just 19 over 9, which we can't simplify. So we just leave it like that. And you should see that A and B have the same solution. So I'm going to circle A and B. There could be more though, so let's just check C and D. Moving on to C. C is a very simple one. You can basically solve it in one step by just dividing both sides by 9. And I'm going to get x is less than 19 over 9. Compare it to the ones above, and yep, it's exactly the same thing. So C also is equivalent. A, B, and C, look at them. They look completely different, but they are equivalent. They're basically the same inequality because they have the same solutions. Let's check D. Negative 5 times x plus 3. I'm going to solve this one by first distributing the negative 5. So like this, distribute. That's negative 5x minus 15 is less than 4x minus 34. We're going to once again collect the x's on the left side, so I'm going to subtract 4x over to the left, like that. That gives me negative 9x minus 15 is less than negative 34. I'm going to add 15 to both sides. That cancels, so it's negative 9x is less than negative 34 plus 15 is negative 19. Yes, it is. Because you subtract the numbers, keep the sign of the larger number, right? We're going to keep it going over here. Negative 9x is less than negative 19. We're going to isolate the x finally by dividing by negative 9 to get rid of the negative 9 there. And then it's just x. But since I'm dividing by a negative, I must flip the inequality symbol. So it has to go the other way now. Greater than, negative over negative is positive, 19 over 9. And there it is. Compared to the other ones, and it looks like it's the same, but it's not, right? This one's saying that x is greater than 19 over 9. So x is a big number. This is saying that x is less than 19 over 9. So x is a small number. So not D. So which ones are equivalent? A, B, and C, because they have the same solutions. All right, let's move on to number 8. It says graph each system of inequalities. Systems of inequalities. Look back at number 4. We did number 4 already before, where we graphed each of these functions of inequalities. We got either solid or dashed lines, and we shaded either above or below. Same thing here, guys, except now there's 2 inequalities in each one. So we're actually going to draw 2 lines for each one, and we're going to shade twice in each one. Okay, so let's get started with A. Here we go. So what I suggest you guys do is focus on one equation at a time, one inequality at a time. Right now I'm going to do that one. I'm not even going to look at the other one. Okay, so I'm going to graph that one that I just circled. In that one, M, the slope, is 2. So I'm going to write it as 2 over 1. And B, the y-intercept, is negative 1. So there you go. I'm going to graph it by beginning at negative 1, right there, and moving up 2 over 1, because the slope is 2 over 1, so go up 2 over 1, right here. Up 2 over 1, right here. Up 2 over 1, right here. I can make as many points as I need to make my line straight. There you go. Next, decide if the graph is supposed to be solid or dashed. In this case, it is dashed. So we're going to draw a dashed line through those points, right? Because it does not have an equal sign. And finally, again, check the inequality symbol to see if it says less than or greater than. Less than, like this one, means below. So shade below the graph, like this. Done with that one. Now, let's do this one. So for that one, it's saying that the slope is negative 3. I'm going to write it as negative 3 over 1. The y-intercept is 2. So I'm going to begin at 2 right here. And I'm going to go down 3 over 1. 1, 2, 3 over 1. Right here for my next point. And keep going 1, 2, 3 over 1. I could make as many points as I need or what I fit in my table, in my coordinate plane, so that I can make my line. Next, decide if the line is supposed to be shaded, dashed, or solid. This one is solid. See the equal sign right there? So this one will be a solid line that passes through like that. And finally, decide if you're supposed to be shade above or below. Again, look at the inequality symbol. Greater than means shade up. So you should shade above the line. So look at where the green line is right here. Shade up above like that. Now we drew two lines, the blue one and the green one. We shaded twice, below for the blue one, above for the green one. The solution really is the intersection of the two shadings. So where did you shade twice? Where did we shade in blue and in green? This space right here. This is the actual solution. This is not the solution. This is not the solution. This is definitely not the solution. It never got shaded. But this right here, where you shaded in blue and in green, that is the actual solution. So that is what you want to highlight. I'm going to show that this right here is a solution. Make that space like the darkest of all, okay? Or what you can do is leave that space shaded, but erase the other ones. Like I would erase this to show, oh, that's not a solution right there. This is not a solution either, right? The solution is only on that right side. All right, let's do it again for B. Once again, one at a time. So I'm going to focus on that one right now. For that one, the slope is -1/2. And the y-intercept is 3. So I'm going to begin at 3 right here. And I'm going to use the slope -1/2 to go down 1/2. Down 1/2. And I could do points on the other side as well by going up 1/2. Like that. Check if it's supposed to be solid or dashed. This one is solid. See the equal sign right there? That means solid. So make a solid line. Like that. And finally, check if it's supposed to be shaded above or below. This one's greater than, so shade above. So I'm going to shade up from the line. Like that. Alright, now let's do the other one. Now the bottom one down here. We're going to use that one by, solve that one, by finding the slope. Again, m equals 1, which is 1/1. b equals 1, right? The slope is 1, whatever's in front of x. The b value, the y-intercept is 1. We start by graphing, by plotting 1 on the beginning on the y-axis. And then the slope, which is up 1/1, like that, to make more points. And now you check if it's supposed to be solid or dashed. This one is supposed to be dashed. See, there's no equal sign, so make a dashed line right there. And finally check, is that supposed to be shaded up or shaded down? Less than means shaded down. So shade down below the graph like this. And again, the question is, where did the shadings intersect? Where did I shade twice? Okay, so you guys can see that I shaded above for the blue one right here, and I shaded below for the green one. Where did the blue lines and the green lines that I shaded intersect? Right in this space right here, right? Not this one, this is only green, this is only blue. This is green and blue right here together. So that's the actual solution right here. This space and everything that falls beyond that space as well, right? These lines keep going forever. So everything that falls beyond that space, that is the solution. So once again, you could make that space darker and darker to make it stand out. Or you could simply erase the other ones that you did to show that these are not the solutions. Right here, this is not the solution, so I can actually get rid of it. Same thing for the blue space over here. This is not a solution, right? It's only that red space that I made extra dark. Okay, C and D are for you. So go ahead and do C and D on your own. Graph them on your own, please. Take as much time as you need. But pause the video right now and then come back to see the correct answers. Okay, so pause the video right now. Okay, here you go. Here are the solutions for part C and part D. So I did them exactly like I did them before, right? The blue one is, let's look at part C. The blue one right here is this one right here, where the y-intercept is +1 and the slope is -3, so -3/1. That's how I drew my line. It is dashed and it is shaded below. The green one is this one, so I began at -2. The slope is up 2/1, so I went up 2/1, and here's my line right here, and it is also dashed. And that one is shaded above. So shaded below the blue one, above the green one, it's right here on the left side. I made it extra dark by shading it in red, and I also erased the portion that I had originally shaded right here, okay, because that's not the solution. The solution is this. Same thing for D. There's the blue one, which is this one right here, where the y-intercept is -2 and the slope is down 1/3. For the green one, the y-intercept is -2, but the slope is up 3/1, so it goes like this. Both of them are dashed, And for the blue one, it's supposed to be shaded above. So I did shade above all of this. I did erase afterwards. And the green one, it's supposed to be shaded below. So I shaded everything below. And this is where the shadings intersected. So I went ahead and made that one darker in red. Those are your solutions. Okay, number 9, graph the piecewise function. Okay, this type of problem we did earlier in the chapter. Actually, it was at the first section of this chapter that we just finished. So it's been a while since we covered it, but we did see it in class. Okay, I told you guys every time you're trying to graph a piecewise function, piecewise meaning that it's in pieces, that have multiple pieces to this function. Make a separate table for each piece. So for example, you're going to make a table for this piece. Those two go together. And another table for this piece. And if there was a third one, you would make another table for that one. Okay, so let's start with the one that I circled in blue. You're going to make an XY table, but instead of XY, what you should put is X, and then instead of Y, put what it is that you're supposed to be plugging into. Okay, so basically put whatever is here, that's your Y. So in this case, 3. So what you're saying here is, I'm going to choose some X values and I'm going to plug them into this right here. Let's make one for the green one. X, and instead of Y, you put negative 3x plus 1. And what you're saying is, I'm going to choose some X values and I'm going to plug them in right here into my function. The choosing of the values is the first important part. There's a couple of important points that you have to pay attention to, but the choosing of the values is the most important part at the beginning. Meaning you have to choose the correct numbers to plug in, because if you don't choose the correct numbers, your graph is not going to look correct. And how do you choose the correct numbers? By looking at this. It's saying for x is less than 1. So what it's saying is choose values that fit this description. Always also choose the number that they give you there. Okay, so I'm going to start with 1 because that's the number that it's telling me to start at. But then I'm going to choose numbers that are less than 1. So 0 and 1, and that's enough. You should not have more than 3 points. Actually, only 2 should be enough. So 1, 0, and negative 1. Actually, not 1. And negative 1, because we want numbers that are less than 1, right? Those should be enough. For this one over here, I'm going to choose values that are greater than or equal to 1, because that's what the inequality there is telling me to do. That's what the domain is. So start with 1, once again. Always start with whatever number that is. But then keep going with numbers that are greater than or equal to 1. Numbers that fit this description. So 2 and 3 and more if you want to, but that should be good enough. Okay? So what you're going to do is you're going to plug in the x values into whatever the function says, and that's how you're going to get what you're going to plug in, what your points are going to be. If it's just a single number like this one, then your job is easy. When you plug in 1 in here, since there is no x to plug it into, what you're going to get back is the exact same thing that you started with, which is just 3. Same thing for 0, and same thing for negative 1. When it's just a single number, there is no x to plug into, you're going to keep getting the same number over and over again. For the green one over here, when I plug in 1, let's do a little bit of mental math. You're going to plug in 1 right here, that's the first one, right? Plug in 1, you're going to get negative 3 times 1, that's negative 3. Negative 3 plus 1, that's negative 2. Let's do it again. Plug in 2. Plug in 2 right here. Negative 3 times 2 is negative 6. Negative 6 plus 1 is negative 5. Plug in 3. 3 right here. Negative 3. 5. Negative 3 times 3 is negative 9. Negative 9 plus 1 is negative 8. So this one's going to be negative 8. And I'm ready to graph. The only thing that you got to watch out for when you graph now is this. Look at what it says here. X is less than 1. Notice that there is no little equal sign below. That does not exist on that one. Therefore, when you start this graph, there should be an open circle right at this point. So right at this one, see the 1 right here, see the 1 right there. Right at this one, there should be an open circle. And open and closed circles represent a point which you cannot cross, right? You're going to stop right there. On the green one, same thing. This right here, see the equal sign right there? That means that right here at this one, there should be a closed circle. This one should be closed. Alright, now we're ready to graph. Let's graph the blue one. It's going to look like this, watch. Start at 1, 3. So 1, 3, right here. Put an open circle there, like that. Then graph 0, 3, which is right here, and negative 1, 3, which is right here, and draw a line to connect the dots. Now the open circle you cannot cross, but the other one you could keep going, right? Because here you could have kept going to negative 2, negative 3, and so on, right? We just want numbers that are less than 1. So draw an arrow on that side to symbolize that it keeps going. For the green one, start with 1, negative 2. Make a closed circle there. 2, negative 5, which is way down here. And 3, negative 8 is beyond my graph. So those two are enough. Connect them. And this one's going to keep going all the way over there, right? Because it keeps going to 3, negative 8, and to 4, and to 5. It keeps going. But the closed circle here, you cannot cross. So it stops right there. And there you go. There's your piecewise function for this situation. Alright, I'm going to let you guys practice on number 10 on your own. So go ahead and try it on your own. Remember, make 2 tables and then graph it and see if you get it right. Come back, pause the video right now, and come back and check your answer. Go ahead and pause the video right now. Okay, here you go. There's the correct graph for number 10. I started with this one. I circled it in blue for values that are greater than 2. So my table started with 2, then 3, then 4. And I'm plugging them in into 2x minus 3. That's what it says. So when you plug in 2, you get 1. When you plug in 3, you get 3. When you plug in 4, you get 5. And also, I circled this to show you guys that this represents if the circle here, see the 2 right there, see the 2 right there, should be open. And the other one is the exact opposite, right? This one has less than or equal to, so this should be closed. That's why I wrote that there. On this one, I use numbers that are less than or equal to 2. So 2, 1, 0, that should be good enough. And then when I plug them in onto this equation here, this expression, I get 7/3, which is approximately 2.33. It's okay to write it as a decimal or leave it as a fraction. I got 5/3 for 1, so it's approximately 1.67. And when I plug in 0, I get 1. And once again, this point should be closed, so I made a closed circle right there at 2.3. And I made an open circle at 2, 1. For the blue one, it's 2, 1, 3, 3, and 4, 5, and it goes like that. For the green one, it's 2, 2.33, 1, 5.3 right here, and 0, 1, and it keeps going that way. You cannot cross past the closed circle or the open circle. Alright, moving on to number 11. It says, write the equation of each line described. A, the slope is 3 and passes through negative 2, 1. Okay. So the slope is 3, but the first thing I'm going to write is m equals 3. And it passes through negative 2, 1, so I'm going to write that there. And I'm going to label that point as x sub 1, y sub 1. What you're going to do for all of these problems is use point slope form to find the solution. Okay, and if you recall, point slope form looks like this. Y minus y sub 1 equals m times x minus x sub 1, like that. So this means that in the middle box you plug in the slope, in this one you plug in the y sub 1, and in this one you plug in the x sub 1. X with the x, y with the y. So using these numbers, I am ready to plug in. The slope is 3, goes in the middle. The negative 2 is x, so it goes here, x sub 1. The 1 is y, so it goes there. Distribute and solve and you're done. Isolate the y to put it in slope-intercept form. So it's going to be y minus 1, let's clean it up, equals 3 times x is 3x. Here, negative 2 becomes positive 2, right? So this is really plus. So it's 3 times 2, which is 6, so plus 6. We're going to add the 1 to cancel it there, and we're done. Y equals 3x plus 7. That's the equation of that line. Alright, I'm going to let you guys try B later, but right now let's skip over to C. Skip over to C. A line that passes through negative 2, 2 and 3, 7. So notice the difference between that one and A. In A, they told me what the slope was. In this one, they're not telling me what the slope was. But I can easily find it from the 2 points they gave me. So what I'm going to do is I'm going to stack the two points. I'm going to put 3, 7 below the negative 2, 2. And I'm going to find a change between the x's and the y's. So in this one, this should look familiar. Check the change. From 2 to 7, by how much did it change? It went up by 5, so plus 5. from -2 to 3, right here, by how much did it change? It also went up by 5. And remember, I kept saying earlier when we were learning this, the slope is always whatever the change in y is divided by whatever the change in x is. So 5 over 5, which is going to be 1. So it's just 1 for the slope. So m equals 1, that's what you're going to use to plug into point slope form again. Then what you do is pick one of the 2 points, either that one or that one, whichever one you like the best, doesn't matter, to use as your x1, y1. I'm going to use this one. It doesn't really matter which one you use. So my equation, again, point slope form, to write your equation, start with point slope form every time. Looks like this, right? M in the middle, and the slope is 1, so plug a 1 in there. 3, 7 is the point we're going to use, so x is 3, that goes here, y is 7, that goes there. So 3 here, 7 there. Y minus 7 equals 1 times x is x, 1 times -3 is -3. Because all I did here, guys, is distribute, distribute, distribute. 1 times x, 1 times -3. Finally, we're going to isolate the y by kicking out the 7, right? We're trying to put it in slope-intercept form. So we isolate the y, and we got x plus 4, and we're done. All right, I'm also going to let you guys practice D on your own in a little bit, but right now let's move on to E. Go to E, please. It says passes through -3, 2, and is parallel to y equals 2x minus 5. In all of these problems, you're going to use the same one we've been using. Y minus y sub 1 equals m times x minus x sub 1, like that. So remember, when you're trying to use that formula, you need the slope, m, and you need a point to put in there. They gave you the point, right? Let's label that one already. This is x sub 1, y sub 1. So actually, we can already plug that in. The x is -3, right there, and the y is 2, right there. The only thing we're missing is the slope, okay? And to find the slope, look at the clue they gave you. It's something that is parallel to this. And earlier in the year, we learned that parallel lines have the exact same slope. So basically, if it's parallel to this one, it must have the same slope as this one. So find the slope of this one, which is 2. And the one that is parallel has to be the same one, so the slope has to be also 2. And that's why we plug in 2 into the formula there, into the point slope. And now we just distribute and solve. We're going to distribute the 2 here. Actually, first look at the -3. That turns positive, right? And then we distribute. So it's going to be y minus 2 equals 2 times x, 2x, 2 times 3, 6. Positive 6 because it became positive 3. Kick out the 2. And you're done. Y equals 2x plus 8. Done. All right, let's look at F. Same setup. They gave me a point, so I'm going to label it x1, y1, x sub 1, y sub 1. I'm once again going to use point slope form, which looks like this, to plug in the numbers. So I'm actually already going to plug in the x and the y. X is 4, x with the x. Y is 1, y with the y. What I'm missing is the slope once again, right? And the clue here says that it's something that is perpendicular to this one. So we learned earlier in the year about parallel lines and also perpendicular lines. Parallel lines have the same slope, like in the example that we just did before this. Perpendicular lines do not have the same slope. Perpendicular lines have slopes that are opposite reciprocals of each other. So for example, look at this one right here. The slope of that one is 3, right? Y equals mx plus b, so the slope is 3. The perpendicular slope, and this is the symbol we use for perpendicular, the perpendicular slope is the opposite of that one, which means that it's negative because that one's positive, so the opposite is negative, and the reciprocal, which is not 3, it's 1 over 3, so -1/3. That's the slope you're supposed to plug in because you want it to be perpendicular. So you're going to get y minus 1, let's distribute here, just like we did before, equals -1 over 3x Negative times negative, right here, negative times negative is going to be positive, plus 1 over 3 times 4. This is 4 over 1, so when you multiply, you're going to get 1 times 4, which is 4, and 3 times 1, which is 3, so 4 over 3. And finally, to put it in slope-intercept form, we're going to add 1 to both sides. And I'm going to get y equals negative 1/3 x plus 4/3 plus 1. That is not that complicated of a problem, guys. It's 1 over 1, right? They don't have the same denominator, so have the common denominator. What is the common denominator for 3 and 1? 3. So what we're going to do is multiply this one times 3 over 3 to make it have the same denominator. So it's 4 over 3 plus 3 over 3, because 1 times 3 is 3, 1 times 3 is 3. That makes 7 over 3. So 4/3 plus 1 is 7/3. And there's your final answer for that one. Okay, here's what you guys are going to do now. I went through A and C and E and F, but now it's your turn. So everything that I skipped, it's up to you to work it out on your own, and then come back and check your answer. That means B and D, and in the next page, G and H. So work on those 4, please, on your own, and then come back and check what the correct answer is. Okay, so let's go through the correct answers for those. Here's B. The slope is -2 and it passes through 3, -2. I label this one x1, y1. I use point slope form. Plugged in the slope, which is -2. They gave that to me, put that in there. The y value is -2, so it goes here. The x value is 3, it goes here. Right here, the only thing you're going to be careful with is the x minus -2. That makes it plus. I distributed the -2. I got -2x plus 6. I subtracted the 2 to isolate the y, and here's your solution. Y equals -2x plus 8. In D, let's go down to D. I labeled this one x1, y1, but you could have used this one also. Either way, you're going to get the same answer, because when I stacked them to find the slope, I noticed that the change in the y's is 0, the change in the x's is 5, or -5 if you went the other way, but it doesn't matter because the numerator is 0, which makes the slope 0. So I use point slope form again. The slope is 0, and I plugged in 2 and 1, but when I multiply times 0, I got nothing but 0 on the right side, and then all I had to do was add the 1 to make y equals 1. That's it. That's your equation. That means this is a horizontal line, right? Whenever you have y equals just a single number, that's a horizontal line. On the other side, G and H, here you go. Here's G. I used x of 1, y sub 1 is -6, -1. The slope is 5 because it's something that is parallel to this one. And so if it's parallel to this one, it has the same slope. Plug in 5 right there for the slope. +1 and -6 over here for the x and the y. That makes it x plus 6, y minus 1 right there. Distribute the 5, you get 5x plus 30. And then kick out the 1 to get y equals 5x plus 31. And then here's H. x1, y1 is -4, 5. The line is perpendicular to this one. So if it's perpendicular to this one, the slope of this one is 4. The perpendicular slope is -1 over 4, right? Opposite, reciprocal. Change the sign and do the reciprocal. That goes here in point slope form. The y is 5, the x is -4, which when I plugged it in, it became +4 because of the x minus -4. Then I distributed the -1/4, I got -1/4 x, and then -1/4 times +4 makes 1. Okay, you can check that by putting a 1 under it and multiplying straight across, but it's basically 4 over 4, which is just 1. And then I kicked out the 5 by adding it. I got 4 right here, and then there's your final answer.